Right guys, next job. So my bid on a rotary table, for those that watched my recent Blether video, came good. So rotary tables turned up. After I thought, just based on the colour scheme, it was hard to tell. This is an eBay purchase, so it's hard to tell off eBay what make it was, and there was no information, and I took a bit of a punt on it, basically. And now it's come, there is actually a badge plate on it, and this is an Apex rotary table. So I've done a bit of research, and here was me thinking it was an old English one, just based on the colours and sort of the age of it. It's actually Indian manufactured, but of the Indian manufactured stuff, these are, they're seen as good quality ones. So we'll see. Yeah, we'll see how we go. So it's a bit big for my machine, to be honest. It's a 10-inch, 250mm table on it, and I've got another video coming up that I've already sort of kicked off when I did the unboxing of this, where the next sort of job, once I finish this rotary table adapter plate, which is for the customer, not for me, is to get this back on the bench, fully stripped, fully cleaned up, refurbed and put back together. So what I've done just for now is I've cleaned up the table surface, I've cleaned up the underside surface, I've put some oil where it needs oil and freed things off, so it's it's in a state that I can use it, just to get this job out the door. It's got, obviously you've got your degrees, full degrees marked on the outside of the table, and there is a 0 mark to line up against, and then there's a graduation on here as well, which goes down to 2 minutes. So I've got 2-minute graduation, so it's quite accurate really, as a vernier scale. I think even the most accurate ones only go down to a minute, and you could subdivide the 2-minute lines anyway, quite easily. So you can be really accurate with this. So what we're going to do, first job, I've got it loaded on the table. As you can see, because of the handle arrangement and because of how big this is, I can't get the T-slot grooves to line up with the T-slots in the table, just because it's too big. But I can sit it over at an angle like this. I can still use it, I can still rotate the table, no problem at all. So I've got it clamped down with a couple of clamps. So the first thing we need to do is pick the centre of the table up, so that I know my spindle is then datumed with the centre of the table. So that's the first job. So I've got my DTI in my dovetail DTI holder in the spindle. So we're just going to get that. We're just going to get that set up now. And I've wound it to somewhere near. So just registering on the clock there, and this clock is really quite sensitive. 1/2 tenth graduations. So that's saying already, it's telling me that I need a bit more weight on, so we'll bring that up to 0. That is probably the best I'm going to get, so that I can get on the clock at the four poles. So we're -5 at the front, plus plenty at the back. $20 at the back. Full turn at the front. 0. 0. 0. Plus the 10th. 0, minus a tenth, 0, 0, 0, 0. So what I'm going to do now is just take this for a spin and just see how concentric this is. Now I've got it zeroed in. That's maximum of 2/10 movement of a thou. There's a bit of a lump in that. Yeah, so we're concentric within a couple of tenths. So that's good enough. So I'm going to zero my dials out at this now. Now the key here is I need to remember, because I'm going to be doing this over the course of several days. So I'm going to get a marker pen and I'm just going to mark on the X and the Y the rotational direction that I've gone in to achieve that 0, so that I know which way my backlash is accounted for when I'm on centre, because I will have forgotten that in the space of the couple of days it's going to take to do what I need to do next. So I've zeroed the X and the Y axis out on the dials, happy with that. So we're set up, ready to go to start building the setup now, put the part on, clock the part in, and then get ready to do the next bit of machining on it. Right guys, I've cut myself some studding. I probably forgot to say this is aluminium. I can't remember whether I said it's aluminium or not, but that's what it is. So here's the part that we turned previously. So that is going to sit hopefully nicely on top of that aluminium piece. I've got, the ideal job will be parallels of the right size and shape and locate them underneath. I just don't have enough gear for that, and that's why I've opted for this lump of aluminium, which I'm sure will do the job fine. So I'll get some clamping gear and we'll come back and we'll get this clocked in to the centre of rotation, and then we're good to go. Okay, I've got a steel clamp plate and a nut on top of there now. We've just nipped that finger tight, and I've set my clock up on the OD of the part on centre line. So what we're going to do now is rotate the part and clock this in until we've got it running concentric with the table rotation. There's two ways I can do this. I can either do it this way, or I could put my clock back in, because I know my spindle now is bang over the centre line of the table. I could sweep round the outside, and I might do both, because that's another double check of how concentric the table's running. So we'll set it up like this first, and then I might just do a double check sweep on the OD of this, just to make sure that we're correct. So we'll see where we're going. I expect this to be a country mile away, which it is. That's 3 and some good bits away at turns. Let's get my knocker. In fact, we'll go back the way and find the lowest point, I think. Which is there. So about 3-4 turns potentially. So if I go, that's a turn, that's 2 turns. See where we are now. So we're about 8 plus 8 minus 6, so that's 14 thou. So if I move this 7, 1, 2, 3, 4, 5, 6, 7, we should be somewhere near. So about 2 thou there now. We'll just re-zero that. +4. -3. So we're within about a tenth and a half, 2/10 there now. I think that's not going to get it much closer than that, so we'll nip that up and watch it all move. Alright guys, we've got this back to back on the table again. So what happened was, or what was happening, in the centre of the rotary table, and this is because I've not stripped it down and I've gone straight on with the job without really understanding it. So there was this piece in the centre, and obviously I'd extended the thread with this bit of studding and this sort of nut, and basically as I was tightening up on the top, this had been kind of glued in with something by the looks of it, and all it was doing was just pulling this out the centre of the rotary table. At the bottom of the rotary table at the back is another bung, you know, right at the very bottom, with the same M12 thread in it. So we've managed to strip it all down at the back, have a look at it, tap that hole out, we put a stud in, we've set it all back up, and I've done it exactly the same way that I showed on camera before. So we clocked the centre of the table, made sure we were XY0, then put the part on, put the clock on the table at the side, and set this in till it's running absolutely concentric. I've got that running within about 2 or 3/10 concentricity, and then I did a sweep with the clock around the outer diameter of this using the spindle, and again I'm measuring 3/10, something like that, with the clock. So quite happy that I'm on centre of the table rotation, and also that the part is running concentric to the table rotation. So we're good to go. So there's 2 patterns of holes that stay in the part, and what I mean by that is they're the fixing holes for the chuck and for the rotary table, and then there's 1 pattern of holes that I'm going to drill, which are for the cutouts, if you want to call it that, the start of the cutouts. So we're going to do the important ones first, which are the ones that are for actually clamping this thing onto the chuck, and there's a real relationship between the concentricity of the part and where this pattern of holes goes. So we're going to do that one first. So there's 3 holes equally spaced on a 92mm pitch circle diameter, which is 46mm radius. And what I'm going to do, because I'm happy with this rotary table that I've got real fine adjustment on it, even though this will be the first time I've used it, I'm going to use what they call polar coordinates for these holes rather than Cartesian coordinates. So I'm going to basically use the rotary table to do all the positioning for the holes rather than using the XY axis. With the XY axis I've got backlash to contend with and consider at each position, whereas using the rotary table I can wind to one position and then just index the rotary table round to the right angle. So that's using polar coordinates. So we're going to start. I need to set up my 46mm position for the first pattern of holes in the Y-axis, and then we'll crack on. I've got 3 M6 holes to drill and tap, so I'll bring you back once I've got my position fixed. Okay, so I've got my 46 radius dialed in now on the Y-axis, got my X and Y-axis locked off, I've got my rotary table locked off and set to 0 on the big graduations and also 0 on the small, on the vernier scale graduations on the handle. So we're good to go, and we'll start with the first hole. Right guys, we're positioned on the next hole pattern now, which is 120 PCD. We've got 4 holes to put in, so same thing, going to go around hole by hole largely, and at least do all the drilling work, and then I'm going to change the chuck out for collet chuck to do the counterboring with an end mill. So we'll start that now. Right guys, next job is to counterbore these 4 holes for a socket head cap screw. So I've loaded up an end mill, got the ER32 collet chuck back in, I've brought the head right down, and we're going to use the quill to feed down to depth. Yeah, not particularly well. Let's slow that down a bit, try it a bit slower. This is a brand new end mill, and I think that's the problem. I think it's too sharp, and it's because it's too sharp, it's chattering, vibrating a bit. Right guys, we've took the edge off the cutter now, and it seems to be cutting better, but I'm having to run this much faster than I'd like for a high-speed steel cutter, so I'm running at 960, but it seems to be coping. So we'll do the last hole. There we go, that's got all of those 4 counterbored. What I'm going to do while I've got the milling chuck up, the next job now is I'm going to start milling out the weight reduction slots, and then the last job then will be to come in and just do a bit of countersinking of these counterbores. So I'll bring you back when we're set up for the milling. Alright guys, I've started with the weight reduction slots. I've just been sorting the method out, so I've cut 2 scallops out already out of the part. I'm just going to start on the 3rd. So basically I'm scalloping in using a 20mm solid carbide slot drill, pecking down millimetre depth at a time, feeding in, and once I've done all, then obviously rotating 90 degrees on the table. Once I've done all 4 like that, I'm then going to move the x-axis across to the same dimension, the other side of the centre line, do the same thing again, 4 places, and that'll be the basically the 4 widths finished off, and then all I've then got to do is pick out then in between the 2 cutouts that I've already done. And I'm trying to do it this way to save trying to mill this at full depth on this setup, on this mill with a 20mm. The drawing calls for a 10mm rad in the corner, and that would just be too much for this. There'd be too much chatter and vibration, so this is the best way of managing it. So I'll film a little bit of that. I'll not film all of it because I'm going to be at this for quite a bit of time, so I'll probably just film a few cuts on this slot, give you the idea, and then I'll bring you back when we're probably finishing off the last slot on the opposite side before we start picking the middle bit out. So you get the idea. I'll bring you back when we've got a few more of those done. Alright guys, bit of a sort of mid-progress update, and I've got some good news and some not so good news. So the good news is, you know, we're making reasonable progress, and it's cutting quite well, and I've now switched my x-axis to the other side of centre line and started nibbling out a few pockets. The bad news is, because I'm just working to a fixed number on my y-axis dial, if you like, unfortunately on this particular slot here I've managed to go 1 turn too many, so I'm 2.5mm deeper than I should be. All the rest of the slots are the right depth apart from this one, which is absolutely no good at all. So however, and again the good news is, I've contacted Derek, who this is for, and had a chat with him and basically said, you know, I've made an ass of it, and basically, would it be a problem if I went down to 105mm as the sort of wasted diameter rather than 110, because obviously I need to match this 2.5mm deep on both sides of the component, so it effectively makes it 5mm smaller on diameter. I've looked at the drawing, it's not an issue I don't think from a stability or rigidity perspective, and what Derek's told me is that the chuck he's actually putting on here is a 4-inch chuck, I think, roughly, so that's only 101.4, so that's still inboard of this bottom diameter at 105, so I've had a bit of a lucky escape with that one, but yeah, highlighting the fact that if I'd had a DRO on the machine, that wouldn't have happened, because I would have been working to a set of numbers on the DRO rather than just trying to count how many turns I've done on the y-axis. So anyway, either way, that's the update. The air was particularly blue when I figured out what I'd done there. So what I'm actually going to do now is I'm going to go and set my, because I've done all the ones on the right hand side of the holes, if you like, as you look at them. So those 4 are done to the right depth. I've started doing the ones on the left hand side of the holes. So this one and this one, which this one's the bad one. I'm going to go and set my cutter to this deepest depth, and I'm just going to go round and spot the other 2 slots at that depth, at the deeper depth, so that I don't go too deep again, so I can work to my mark on the face. So that's how I'm going to control it. And then once I've got these 4 done, this side of centre line to the new deeper depth, I'll then pitch across back to the other side of centre line, and I'll bring the other 4 slots to the same depth. So I'll bring you back when I've done a load of that work. Right guys, I'm not going to use the word rectified, because that would suggest that I've made it to drawing. So I'm going to use the word reworked. So that's been reworked to the new standard. So all of the slots are now at the 105 diameter, if you want to call it that, across the part. So the next thing I need to do now is take out the centre segments in between, the 4 centre segments in between. To do that, there's a couple of ways I can do that. I can either put the tool back on centre and pitch in using the y-axis of the mill itself, in the same way that I've pitched into the slots, or I can try and mill it using the actual rotary table itself. Now, this rotary table is new to me. I don't know how that's going to go. Obviously there's a worm and worm wheel in here, and there'll be backlash associated with that, so we're going to give it a whirl and see what happens. If I'm struggling with that, then I will revert back to just using the machine's y-axis and lock the table up solid with the lock. What I've also done is I've pitched out by 0.5 millimetre, so I'm going to leave myself 0.5 millimetre stock on whatever I mill here, and I'm basically just going to keep pitching backwards and forwards and dropping down probably 1 millimetre at a time. We'll see how it goes. So we'll give that a shot. That seems to be coping quite well. I'll keep plugging away at that, and I'll bring you back probably once I've got the first one out and show you what that looks like. Alright guys, that's the first one done, and that's come out very nice actually. Steady away, 1 mil depths of cut, taking the middle bit out, and then I pitched back in 0.5 mil and joined it all together, and that's looking really nice. I'm quite pleased actually with how this rotary table's behaving. So I'll crack on, get the other three done to the same standard, and I'll bring you back when we get to the end of that bit. But so far so good. Right, well, there we go, guys. That's all 4 pockets done. Really pleased with that. That's well, other than the fact that it's the wrong size, but yeah, Derek assures me that it's not an issue. So yeah, I'm really pleased with how that's come out. I was looking forward to doing that. It's something a little bit more interesting than just milling square things. So yeah, what's left to do now is I need to countersink these 4 holes, and then obviously all of this needs to be deburred. I don't know yet whether I'm going to do that on the rotary table or not. I might just see if I can do these edges on the rotary table at least. I'm obviously not going to be able to do the corners unless I'd got a 20mm diameter chamfering tool to get into those, because obviously I can't interpolate around that radius, so I'd need to form it. So yeah, I'll think about that. I'll think how I'm going to do that. I think there might be a bit of file work, whether I do it all by file or bit by machine and then blend it with the file, I'm not sure yet. But yeah, really pleased with how that's come out. That's looking really smart. Okay, I'll bring you back when we're popping the countersinks in, and then that'll just about be finishing this piece off. Right guys, we're just going to countersink these 4 counterbores now, so we'll get on with that. There we go, that's that done. I'm just going to see if we can set up now for doing a bit of chamfering. We'll just see what I've got, and I'll bring you back if we're doing that on the machine. Alright guys, I've got a chamfer tool set up and I'm just working my way around the part with that, so I'll just show you a little bit of that and how that's working. Again, the rotary table is really handy for this, and the fact that we've got regularly spaced features. I can just do a feature index, and like that, so it's working out really well. So I'll just show you a bit of that. So you get the idea. I'm just going to pitch across now, do the same thing on the other 4 sides, and then I'll pitch in between and do some chamfering, you know, on the diameter portion, and then I'll just have probably a tiny bit of blending to do in the corners here. So that'll be much better than doing it all with a file. Well, there we go guys, that's that piece completed, other than chemical black. So I spoke to Derek and said, do you want me to have a go at chemical blacking? I think this bit will black up okay. The silver steel piece that I'm about to make to locate this in the rotary table probably won't, but we'll give it a try. So that's all been complete. I've done the same thing on the back side in terms of I reset it back up on the rotary table and machined the chamfers in, and then all I've done is just used like a rat tail needle file to blend these corners in on both sides. So that's that part complete. I'm really pleased with that. For a bloke fooling around in his garage, I think that's a nice piece of ironmongery there. So pleased with that. Pleased with the rotary table, albeit it needs a good strip down and clean and everything, as I've already discussed, and that'll be another video. I'll do that as a separate thing. So yeah, that's, other than chemical black, I'll bring you back when I'm doing that, but I'll get that just oiled up for now, just so that it doesn't go rusty and wrapped up, and we'll start on the silver steel piece that's going to locate in the centre bore. I've got a Morse taper to turn on one end of it, so we'll set up on the lathe next for that part of the project.